Guys, hear me okay? Okay. So today I'm going to talk about architecting a virtual infrastructure. And the main thing that I want to emphasize today that it's not about actually building it, but it's about making the right plans and executing on those plans, because that's the most important thing if you ask me. So the agenda by itself is fairly straightforward. I will do a short introduction. I will discuss some of the design methodology. And then I will go over some of the design patterns. And then hopefully we'll have some time left for the Q&A. But considering I have about 40 slides, that's going to be pretty tight, I guess. So as mentioned, my name is Duncan Epping. I'm a principal architect working for VMware, and I'm actually part of R&D these days. So I'm part of the integration engineering team, as they call it. And basically what I do during the day is what you guys do during the day as well. So I play with our solution, software, try to figure out how it works. And if it doesn't work, I'll file a bug and hopefully the engineers will solve it for us. So that's my main job role. So if you hit any issues or are experiencing, for instance, severe issues in your environment, don't hesitate to let me know during the day as well. So just come up, have a chat about what kind of issues you are facing, and hopefully VMware can solve them for you in the future. So as I just mentioned, the session is about designing a VMware-based infrastructure. It was originally intended to be an interactive session, so if you have any comments, questions, feedback, specific experience you had during the creation of a design or during the implementation, feel free to speak up. I understand it's difficult as a non-native speaker, but realize most of the people here are non-native speakers, so am I, so it's okay if you make mistakes. So let's get into it straight away. First of all, let me ask a question. Have people actually read Scott Lowe's design book? So I read the design book, and this is probably one of the principles that's part of the design book. And the reason I wanted to emphasize this is the phase that a lot of people, when they do an architecture, actually skip. Everyone wants to dive into the actual technology bit itself. But the most important part, if you ask me, is you start off with a vision. You sit down with your customer, you try to figure out what their plans are, what their ultimate goal is essentially to get out of the solution that you're building, and that's the kind of stuff that you're going to document. Now out of that comes an architecture, and part of that architecture is not just an architectural document, but that could also contain, for instance, a test plan, but also operational guidance, for instance, on how to manage an environment. Now, after you created this architecture, it's time to do some planning, and that's also typically a phase that a lot of people skip. What I've seen out in the past is that a sales guy comes in, he pitches a project, and he says, well, it's going to take us 3 weeks. Well, how does he know that it's going to take them 3 weeks? Because he hasn't actually spoken about the architecture itself. That's typically what you guys should be for, or at least you guys should be doing. Make sure that he doesn't sell a 3-week project. Well, in reality, it might be 6 weeks, 9 weeks, or who knows, maybe even 12 months. So as soon as you've done the planning, that's the point where you actually get into the real implementation itself, which is what we call the transition phase. But this is where we actually implement what we've architected. Now, this is typically the shortest part of the overall project, and that's what surprises a lot of people. The majority of the time actually goes into the architecture, and typically the implementing part is just fitting the components or placing components in the right spots. Now, as soon as you've done that, in my opinion, comes the most critical phase of any project, and that's the managed aspect. In other words, sit down with your customer, show them what you've created. Not only show them what you've created, but actually show them how they should be managing it. Because if they're not managing it correctly, although you might build, a really great environment, it looks awesome, you got all the right components in there, EMC, VMAX, fastest HP blades, you name it. If they don't know how to manage it, if they set it up incorrectly, I'm sure your project in the end will fail, and the customer won't be happy, so they won't be coming back. Now, I did this session at Partner Exchange at the Emerald, or at Partner Exchange in Las Vegas. And we started talking about gathering input, and we had a room full of consultants. So my first question was, what's the first thing you do when you start a project? And no one really had the answer. It's fairly simple. You start talking to your customer. And the whole room started laughing, but the majority of the people never really had a conversation with the customer about what their ultimate goal was. What do you want to get out of this project, right? We understand you want to virtualize some applications, but what exactly is that about? Are there any specific business drivers, for instance? And we'll get into that into a second as well. But as soon as you have those discussions, make sure when you have those discussions, you actually document some of the decisions or some of the comments made by your customers. Because I can guarantee you that some of the decisions made along the way, at some point the customer is going to say, well, you know, I never told you to do that. I'm pretty sure you did. It's documented over here. You actually signed it off. So as soon as you start documenting, make sure you document these constraints, requirements, assumptions, risks, all of those things, because they are very important to the success of any project. So as I just said, the thing that you always want to talk about first is what would you like to achieve? In most of the projects I've been, it's either cost reduction, or for instance, it's time to market for a specific business unit, or it's increasing resiliency, for instance. So those are the things you typically want to figure out. Now, what I always do in a design is I try to visualize, for instance, what our goal is. So in this case, this is an example of decreasing the time to market for a specific application for a business unit. So I've done probably hundreds of these type of projects, but the big question was how can we reduce the amount of time needed to deploy a specific service for our customers? I said, well, virtualization is the first step, but then what? So I did a project at a large bank, and this was more or less the process that they had set up. So they had a virtualization layer in place, and standing up a virtual machine took about 5 minutes. Standing up multiple virtual machines and some storage and networking took about a day. So how long do you think the change process was for that full day of work? It was about 6 weeks. So it's not only about making changes to the infrastructure itself, but making sure that the people understand that those changes will also need to be reflected in the organization itself. So the organization will need to adopt the technology that you're proposing. So in this case, for instance, the vision could be creating a software-defined data center. And Scott Model has also mentioned software-defined networking. This morning explained some of the technology. Of course, that's part of it. Cormac is going to discuss software-defined storage this afternoon, so make sure you attend the session as well. Now, when you go through the discussions with your customer, in my opinion, there's always one thing that really stands out. That's the sender. And when I created this diagram on the lower left or the lower right for you guys, there's a reason the application is in the middle. It's something that a lot of the infrastructure architects tend to forget. The virtual machine itself, or the hardware that it's running on, is not really that important, right? So it's nice that you have HP or Dell or IBM or whichever vendor it may be, but in the end, your customer is only going to care about the application itself. Is it up running? And is it performing as it should be performing? That's the only thing your customer will care about. It's about the availability and the performance of your application. It's not about the type of hardware that you're running. And that's the kind of stuff that you will need to document as well. So what does that typically look like? Is anyone a VMware consultancy partner in the room, by any chance? Okay, so for most of the people, this is new. If you ever seen these guys, what they normally should do, or in my opinion, what they should go through, is they should document some of these business requirements. Now, in this case that I already mentioned, I just pulled out a random one, which is B104, provisioning based on predefined policies, because it fits nicely with the software-defined data center theme. But that could, for instance, be a business requirement. Another one could be lowering the time to market, as I already mentioned, or increasing availability for our application. But make sure you document these, because this is typically what a customer signs off on. Now, of course, there is also the technical aspect. Do we need to integrate with specific systems? Is there some sort of CMDB system that we need to integrate with? How do we integrate with it? Is there some sort of funding portal that people should be using for self-provisioning? I know Massimo will probably scream, hey, we've got VCD for that, but there are also other systems out there that we can integrate with, for instance. Another option would be orchestrating, for instance, disaster recovery. If that's a technical requirement, you know you're going to have limitations in the type of products or solutions you can offer, right? Although you can fully script a DR solution, scripting a DR solution isn't, for instance, as reliable as using site recovery management. So based on those technical requirements and business requirements, you can start determining what kind of products, features you need to have in your solution. Now, the constraints part typically for a lot of people has a negative aspect to it. They feel they are more or less bound to a specific solution. Now, constraints to me aren't really negative. It's not something negative. The fact that I have a net array is not a negative thing. It's just I need to be able to use that in my platform or in my solution by itself. So I need to take that into account when I start doing my architecture, because it's going to drive some of the other decisions that I make. If I have a net array, there might be specific requirements from a networking perspective. There might be specific requirements from a connection perspective, if you look at it from the host side. So that all of these constraints might at some point drive some of the decisions that you make. And then, of course, there's the list of assumptions. Now, assumptions are things that typically you have validated or verified with your customers. So, in other words, you're assuming that sufficient power and cooling is available. And it's a typical mistake I've seen. A lot of people actually assume that sufficient power and cooling is available, and when they power on the VMAX, they figure that, hey, it's actually consuming a lot more power than I expected, and the whole environment goes down. Or there's only one power line coming into the building, right? And if there's a power cut for whatever reason, whole data center freezes up. And I've seen it happening in hospitals, for instance, which is not a pretty sight where that happens. For instance, sufficient rack space available, again, something that a lot of people assume. Typically something that, in my opinion, you should be validating. I'm guessing most of the people are here for more, get to know more about design patterns, or at least the technical aspect of it. So I carved it up in multiple sections. First of all, the sizing and scaling. Secondly, I will discuss some of the hosts consideration, networking, storage, and some of the virtual constructs like HA clustering, DNS, vCenter data centers, things like that. So we've already mentioned the use case and what an environment looks like. Again, for your design pattern by itself, this is really important as well. So why is this important? Just think about vCenter, for instance. A vCenter, when you create a new environment, the first thing you need to do is create a virtual data center. So are you going to create one, or are you going to create multiple virtual data centers, and what's the impact of that? So how many people realize that if you create multiple vCenters or multiple virtual data centers within vCenter server, that you can't actually migrate virtual machines between those two data centers? So a data center is a vMotion boundary. It's not only a vMotion boundary, it's also a boundary for your virtual distributed switch, for instance. So as soon as you start going over these decisions, yeah, you might have multiple sites, but although you have multiple sites, you might want to have a single data center, so you can still move virtual machines around between those clusters, for instance. So take things like that into consideration. Now, as soon as you start doing sizing and scaling, one thing, in my opinion, that's really important to do is create some sort of report. Has anyone seen, for instance, we have a capacity planner report? So I've done various of these exercises, and the nice thing about these reports is that they always typically look the same. So from a compute perspective, networking perspective, the diagrams all look similar. There's a reason for it. Most of the environments out there were underutilized. So there's a couple of hosts, a couple of operating system applications that do require a lot of resources. 90–95% of their applications don't. So all of them end up looking the same. So why do we create these reports? What are you looking for? Well, you're looking for some of the peak values. Because as soon as you start doing sizing and scaling, you need to make sure that not only you'll be able to cater for the average, for instance, but also for those peak moments. So there might be a virtual machine or an application that does 5,000 IOPS once a month, just because people are running a report, or it's driving 500 megabytes per second worth of network traffic. That's the kind of stuff that you want to figure out from a report like this. And as I said, mostly these will look the same, so you really need to try to spot these peak values. So as soon as you figured out what the estate looks like, so how many virtual machines would I end up with? What's the total amount of resources that are required, amount of megahertz, amount of gigahertz, gigabytes, storage, networking, now what? So you're going to try to figure out how many hosts you'll need, how many LANs you will need, or how many performance those LANs will drive. And for instance, in the case of a host, you need to try to figure out how many virtual machines do I want to run on a single host. So how many people are running more than 50 VMs on a host? Just a couple. Anyone more than 100? More than 150? Not a lot. So 100 virtual machines on a host is, is pretty substantial. It's a fairly significant amount. So what happens if that host fails? It means that 100 virtual machines will need to be restarted at some point. So that's going to have an impact on the environment. Not only will it have an impact on storage, because you will see a massive boot store, but it might also have an impact on, for instance, the other virtual machines that are sitting on the same host. So if you're running 100 virtual machines on a host, it might be smart to have, let's say, 16 or, depending on the size of the environment, of course, but a relative large amount of hosts as well, because at least when there is when a failover occurs, the virtual machines are balanced across multiple hosts. Now the other thing is, what about maintenance? So how long do you think it takes when you enter maintenance mode for a single host? When there's 100 virtual machines sitting there. I can tell you it typically takes, if you're unlucky, 30, or if you're lucky, 30 minutes. If you're unlucky, it could take 4 hours. Because it's going to fully depend on the application itself, what the application is doing. The amount of memory blocks that are changing, because memory blocks are being copied over when a vMotion occurs. And if there's a lot of changes, you will need to keep on copying and copying and copying, and that will take a while. I guess the good news is, with vSphere 5.0 and 5.1, we made a lot of changes to vMotion itself. So you can have multiple NICs for vMotion, for instance. You can have multiple 10-gig NICs even. So this has reduced the time that it takes to migrate virtual machines significantly. The other cool thing in vSphere 5.0 and 5.1, in my opinion, is what we call SDPS, slow down during page send. So what if you have multiple sites and the VM needs to be migrated, but there's a significant amount of latency on the connection between those sites? In the old days, 4.1 and before, the vMotion would simply fail. It would just stop. And if you're lucky, your VM would still be up and running. If you're unlucky, you were in kind of a shady state. You had a ghosted virtual machine, which was more or less already doing something, not a lot. And then there was a virtual machine up and running. You ended up troubleshooting it. Now with 5.0, we slowed down during page, and what we did is we created this buffer size framework. So basically what it does, as soon as we notice that latency is going up, we change the buffer size for copying blocks between the hosts. It's a fairly smart way of allowing vMotion to occur between sites with high latency. You can go up to 10 milliseconds. So for instance, for a stretch storage solution, stretch cluster solutions, it's quite useful. But as I just mentioned, we did these, most of the enhancements, basically to increase or to decrease the amount of time it takes to place a host in maintenance mode. So this is one of the tests that we did. And we were using the exact same bandwidth, but just by optimizing the way the vMotion internally works, there's a 5x improvement between 4.1 and 5.0.
So what was the configuration on the vSphere 5? Was that multiple NICs to get that to the one pushing?
So for 4.1, yeah. So for 4.1, what they did is they had a 10-gig link. They tried an Ether channel. I don't know if people are using Ether channels or not, in my opinion, you can avoid them, and there's a good reason for it. I will come back to that in a second. But with what they tried in Ether channel, the thing with vMotion traffic is, an Ether channel uses IP source destination hashing. If the source and the destination is the same, it always uses the same link. So although you have 2 or 4 or 8 links available in your Ether channel, because the source and the destination address is exactly the same, it will use the same link. Now what we did with 5.0 is we allow you to create multiple VM kernels. So instead of doing Ether channels or whatever, you just create multiple VM kernels, and vSphere by itself decides which link it's going to use based on how it's utilized. That's one of the enhancements. On top of that, they more or less changed the algorithm that was part of vMotion as well. So they rewrote half of the vMotion stack just to make it more efficient.
So it's the multiple VM kernel parts that make the big difference?
It's a combination of both. So they actually tested it with a single vMotion VM kernel as well, and it was still a 3 point something enhancement. It's free.